All right, so next we're going to talk about greatest common factors. So common factors are factors that two numbers have in common, right? Or divisors that two numbers have in common. The greatest common factor is the largest integer that is a factor of two or more integers, okay? So for example, if we have 18 and 42, we want to find the largest factor that they have in common, right? So we want to think about all the factors of 18, all the factors of 42. And there's a couple ways we can do this. One is we can list out all the factors and then pick which one is the largest. But that's sometimes a little bit tricky because it's hard to know when we've exhausted our list of factors. And so one strategy is to use the prime factorization. Okay, so what we're going to do is we're going to prime factorize the numbers that we're trying to find the greatest common factor for. So for here we have 18 and 42. So the prime factorization of 18, if I broke this down, it would be 2 times 9, and then that would be 3 times 3, right? If I broke down 42, it would be 2 times 21. 21's not prime, 3 goes into it 7 times, right? So these are the prime factors, right? Would be 2, 3, 3 for 18, and then 2, 3, 7 for 42. And so I want to find out which of these they have in common. Well, they each have a 2 here, and they each have a 3, right? So 2 times 3 would be their GCF, and that equals 6, right? So their GCF is 6. So that's the largest number that goes into 18 and 42, the largest factor that 42 and 18 have in common, okay? All right, so here's one thing. If the two integers have no common prime factors, then their GCF is 1, right? So every pair of numbers has a common factor, and if it's not, if there's no prime factors that they have in common, then it's going to be 1. 1 is the greatest common factor, okay? Because we know 1 goes into everything, right? 1 is a divisor of any number. All right, so let's see some examples. So we just did number 14, right? The GCF between 18 and 42 is 6. Okay. All right. So let's try number 16, 42, and 70. So what I would do is I would get these numbers and break them down into their prime factorization, right? So 42, 2 goes in 21 times. We just did this one, 3 and 7. And if you did one before, you don't have to necessarily break it down to a tree. You can just write out the prime factors. And remember, we're not using 21 because 21 is not prime. So we're just using the prime factors when we evaluate these. So 70 is 7 times 10, right? I knew that. And then 10 is 2 times 5. So what do these have in common? They have a 2 in common, and they have a 7 in common, right? So here we would multiply 2 by 7, and we would get 14. So 14 is our greatest common factor between 42 and 70. And by the way, I think we used this term already, or this abbreviation, but GCF is the abbreviation for greatest common factor, right? So sometimes you'll hear me say GCF. All right, so 18. So I know 5 goes in all these numbers, right? So if you, sometimes you can use intuition, right? 5 goes in all these numbers. The only number that, the only other number that goes into 15 is 3. So remember, for it to be a common factor, it has to be common with all 3 of these terms. So, and so if, does 3 go into 35? No. So since 3 does not go into 35, that means 5 is the only common factor that works with 15 and 35. And so, and we know 5 goes into 45 as well, right? So 5 is the GCF. So sometimes you might be able to do it without breaking all the numbers down into a factor tree or to a list of prime factors. So it kind of just depends. All right, let's take a look at number 20. So 20, I have 66, 72, and 120, right? So 66 is 6 times 11. 6 is 2 times 3. 11 is prime, so we're done there. 72 is 2 times 36. 36 is 6 times 6. We have 2 and 3. It's a funny 3. And then 6 is 2 and 3. And 120 is 10 times 12, right? 2 times 5. 12 is 2 times 6, which is 2 times 3. So remember, we're looking for what they all have in common. So they each have a 2 in common, and they each have a 3 in common, right? And then beyond that, the only other thing that 66 has an 11, and neither 72 nor 120 has an 11 as a factor, and so 2 and 3 are only prime factors. So even though 72 and 120 have more things in common, right? They have another 2, and but we can't use them because they have to be common with all 3 terms. All right, so that means 2 times 3 is our common factor, and that equals 6, right? So, all right, so 22. So we have 81, 200, and 539. So 81 is 9 times 9, and each of those break down to a pair of 3s, right? 200 is 2 times 100. 100 is 10 times 10. And if you remember the prime factors of 100, you can just write them out. You don't have to break down the tree. But 81 and 200 don't have any common factors, right? So we don't even have to break down 539 because we already know that the greatest common factor between 81 and 200, since they don't share any prime numbers, the GCF is going to be 1, right? And so since that's the biggest number that is common with these two, there can't be anything bigger that also is in common with 539, right? So here GCF is 1.